let's get going on the Bitcoin dev kit. The What we're going to be building here is a mobile wallet, right? An Android wallet, and the main tool that allows us to do this today, the tool that I'm leveraging here, is called the Bitcoin dev kit. The Bitcoin dev kit is a library that is not initially built for mobile. It's not a Kotlin or a Java library. It's a Rust library. And I think the Bitcoin dev kit, and the really cool thing about the Bitcoin dev kit right now too, is that there's two lead maintainers on the project, Alekos and Steve Myers. And Steve is with us here today. He's like listening in from somewhere on the West Coast. So it's very, very early for him. So hi to Steve. And so Steve, you can correct me if I'm wrong, but I think the Bitcoin dev kit mostly started sometime in April, May, not that just came by, but the one before that, in June. And so that's sort of like the time at which it started ramping up. And I heard about it first when Square Crypto sort of tweeted it and promoted the project. And that's sort of how I reached out and started contributing to it. And the Bitcoin dev kit, just to give you an idea, also the thing that happened was that there was another project called the Magical Bitcoin wallet, I think, which was sort of pursuing similar goals. And after a few months of like the two projects sort of like doing well and like pursuing similar ideals and approaches, they connected, and then the teams eventually decided to just join forces. And so since then, the Magical Bitcoin wallet has sort of rebranded to be the Bitcoin dev kit. So the Bitcoin dev kit sort of kept the name, but a lot of the code actually came from Magical Bitcoin. So they were more advanced on some of the code side, the Rust side. So then a lot of the code is from the Magical Bitcoin wallet project. And that's a bit older than the Bitcoin dev kit, like a few months older, I think. So that gives you an idea. And I'm going to maybe screen share because I want to show you a little bit about what the Bitcoin dev kit is. So the Bitcoin dev kit, if you look at the org on GitHub, you'll find that it's actually a sort of like an ecosystem of repositories. I'd say 3-4 of them are like the main ones, but the mothership of it all, of the whole Bitcoin dev kit project, is a Rust library, and it's this one here, BDK. And so BDK is at 632 commits, 19 contributors. There's a nice logo. Feel free to take some time to look at this. And you'll find that we also have a Discord chat. So I put that in a link, the invite. It's a completely open Discord server. I put the link in the PDF document. So feel free to join our server. I want to see some people join today. And there we have a bunch of channels, including some for Android. So if you're an Android dev and you want to pursue that kind of stuff, we have a channel just for Android. So that's cool. And so the Bitcoin dev kit is a Rust library, and but it comes with other repositories as well that are super useful. One that we're going to spend time on today is the Bitcoin CLI, the BDK CLI. So the Bitcoin dev kit has sort of a window to it, which you use the CLI basically to discover or use and test with the Bitcoin dev kit. And it's a really, really, really cool project. So, and this is maintained by the same people. So, and I really recommend you check it out, because if you want to understand from a user's perspective, the application level, how do you use Bitcoin dev kit, the CLI is a really good example of that. And it gives you an idea of like the workflow. If you understand the workflow of like how we're using the Bitcoin dev kit to create wallets using wallet descriptors, and then PSBTs for creating the transactions, signing the transactions, and broadcasting them, it'll give you a really clean idea of how you port that idea to other applications, including if you end up building Rust applications with the BDK, or if you build Android applications. So you'll find that when we go through the Bitcoin dev kit with the Android app, it's the same workflow as with the CLI. It's very similar. So we're creating these wallets, and then the PSBTs get sort of like created, signed, broadcast, that kind of stuff. So the BDK CLI is super important, and we're gonna spend some time on it today. And another important part of this ecosystem, and the one that we're interested in for Android, is called BDK JNI. And JNI stands for Java Native Interface, and it's at the moment it's the solution that we're using to create language bindings between Rust, which is the main library, and the Java runtime. So, and in this case, actually the Android runtime, which is called Art, but you can think of it as the JVM basically. And so JNI provides us that connection there, that sort of glue that we use. We use Rust actually, but there's like Kotlin objects that we can call and just basically play with. And I want to take time to talk about language bindings and like what language bindings are and why they're difficult and why they're important. So if you're not familiar with language bindings, the idea is that you can create libraries in one language that compile maybe to machine code, right? So you're targeting a particular architecture, and then you have other languages connecting to that and speaking as if they were using Java objects, for example, but actually they're not, right? So this is what we do here with the Bitcoin Dev Kit. And what the approach there is that if we can create good language bindings between this Rust native code that we write, right, which has beautiful properties. So if you write Rust, I'm not sure how much you've heard about Rust or how familiar you are with Rust, but if you've heard that Rust is a very important language for the Bitcoin ecosystem, I hope this is me reiterating that idea again. Like Rust is going to continue to take even more and more sort of like market share of the Bitcoin ecosystem for a lot of like systems programming, for speed, for safety. This is where really Rust excels. The place where Rust is not as like developed is for like application level things. So a lot of people, when you develop, like if you develop a desktop app or, you know, like a web app, for example, or an Android, none of that is really written in Rust. But a lot of like the low level, all the systems programming, system stuff it's all Rust, and that's where it's going more and more and more. And so we'd like to be able to combine these two, right? We want to have a library that is written in Rust, so it has the properties of speed and safety, but it also is usable on the application side. And instead of having native libraries that are maybe written, for example, you'll be able to find like Python Bitcoin libraries or JavaScript Bitcoin libraries, or you might be familiar with the Java, it's called Bitcoin J, the Java Bitcoin library, right? All these languages have their own library. Kotlin even has one. Dart has a Bitcoin library. The problem with these libraries is that we're basically spreading the work here, and a lot of, in this case, you know, there's a lot of like security critical things, right? So we're looking at code that you want a lot of review on, you want a lot of eyes on that code, you want to make sure that it's like stable and that it's very safe. You don't want to have any bugs and that kind of stuff. So the further away you get from like the big maintained library, the harder it is to get that sort of like oversight and to make sure that what you're using is really safe, right? So for example, for me, I'm an applications level engineer, so I don't write the Rust code, and I don't necessarily trust myself to write it if I had to do it from scratch, right? So it's important that I don't actually do it from scratch and I leverage somebody else's code. But if we all write our own libraries, it's sort of like spreading thin the resources. And so the idea there is we're going to write one library. This is for building wallets and in Rust. And once we do that, we'll be able to expose that code to all the other languages. Now, it's not that easy, but this is the idea, right? If you can write Rust library that you can compile to machine code for a target architecture, so say a mobile device or your Linux desktop or your Mac laptop, once you have that native code, you can then write libraries in other languages that simply tap into it. And that's all fun and, you know, beautiful, and you're thinking, wow, why don't we do everything like that, right? And the reason why we don't do everything like that is that it's actually very complicated. And the reason why it's complicated is because when you cross the boundaries between languages and between source code, basically, you're crossing the boundaries of memory models, memory management, right? So if you think of languages that have garbage collectors and virtual machines, like Java, for example, Kotlin uses the JVM as well, but anything like JavaScript, Python, these are all garbage collected, right? They have virtual machines, even though we don't really say the Python virtual machine, but Python has some sort of virtual machine, right? And so it needs to manage memory for you, which is really safe, and we like these features, but the Rust side, it doesn't have that, right? Or if you were to write some C or C++, you manage memory manually. So you need to allocate, deallocate. And so these objects that you're passing through between the two need to understand when it's time for the garbage collector to let it go, or for the Rust side to deallocate something. So, and that's where the complication happens there. That's why the language bindings are not an easy feature to accomplish. But if we can do it, then there's huge upside there. So that's kind of like that's the sort of like the backdrop of this whole storyline right now, is that we have this Bitcoin dev kit. It's a Rust library, and that's really the mother of all. So when you think of the Bitcoin dev kit, if you use the Bitcoin dev kit on Android, BDK JNI, you're simply using wrappers around that library. There's no extra features that are coming from BDK JNI, or there are no features that are coming just on the CLI that are not accessible on the real BDK. And so it's not a one-to-one relationship, because if you develop an application in Rust, there's a lot of features that are only in the Rust library right now. But slowly, as users are coming in, and you guys are now becoming users of the Bitcoin dev kit, by the end of the day, you'll have an idea, and maybe you'll want to put it in applications that you know of, or that you use, or that you want to develop. And as the users are starting to flow in, they have more and more requests, right? They're like, well, why don't we want to see this, we want to use this, we want to do that. And as these requests come in, we're sort of like incentivized to build even more that sort of language binding part, or the CLI for testing, or for exploring the BDK. So that's kind of how it works. As requests, as features are requested and needed for developing applications that are outside of Rust, then those sort of trickle down into the JNI and the CLI. And one last thing I want to say about this is that the Java native interface right now is not the final version of the language bindings, because there's another project that's very close to the Bitcoin dev kit. It's called the Lightning dev kit. And the Lightning dev kit is it's a completely different set of repositories, but I think the two teams are thinking of them, or would like to think of them, as sister projects. So if you're developing a wallet, eventually what we'd like to do is to see people being able to develop with the Lightning dev kit and the Bitcoin dev kit, just like jointly, those two really working well together, and the APIs being streamlined, and they make sense. So they stay separate libraries. But if you're developing a Bitcoin wallet, eventually that line between Bitcoin and Lightning is going to blur even more, right? So what I foresee is a situation in which, like, you probably pull both of those as dependencies, and you're just like building a wallet using both of them. So that's super cool. And the Lightning dev kit is supported by Square Crypto. And Square Crypto has put a lot of effort into the language bindings that they have for the Lightning dev kit. And so they're doing a slightly different approach than what we're doing here with the JNI. And I think the Bitcoin dev kit team recognizes that this is the optimized way to do it. It's the better way to do it. And eventually that's what we're working on, is to port our language bindings to that approach. And once that's done, it will actually open up a lot more of the Bitcoin dev kit API. So that's fun too. We'll be a bit more like first-class citizens, if you will, because right now the JNI is really, you pick and choose what you can, and then you'll see today we have like a bunch of stuff, but there are things that you wish you had, and they need to be implemented basically. But if this is something that interests you, BDK JNI, we are 100% looking for contributors. If you're interested in, come talk to us, definitely. The next thing I want to do will require a bit of command line for you folks, so bear with me, and you'll have to, you'll see how it goes. And the next half hour, I want to spend it on the CLI. You should know what the CLI does, how it works, and why it's so cool. And that should be your first thought. Like when you have a problem with the Bitcoin dev kit, you should have notes that you've written somewhere on like a bunch of wallets that you're familiar with, right? That you've made transactions on testnet, and you just like grab those, throw them in your CLI, and start playing with it. Any time you put this week on the CLI for the Bitcoin dev kit will be very, very well worth your energy and your time. So it's like this really cool tool, and it will transfer later on into the JNI and anything else you want to do with the Bitcoin dev kit. So I highly recommend it. So the first thing we're going to do here is take a look at the README on the BDK CLI. And there's not much. It's basically how to install it, right? And I know I was told that not a lot of you are familiar with Rust. So I want to take a minute maybe to discuss Rust a little bit and to give you a sense for what it does. It's not a workshop on Rust, but I think it's important to get a sense for why Rust is what it is and why it's the right choice for the Bitcoin dev kit. And without getting too political here with the languages and whatnot, I know this is a big thing, but you're familiar with, maybe C, C++ versus Java, Python, JavaScript, for example, right? The big divide between those two is that with C and C++, you manage memory manually. So you need to allocate memory and deallocate it when it's time for that memory to go. And if you don't, you have memory leaks. And so this idea of having memory leaks and managing memory manually is very old. And we've developed a huge amount of software on this, right? Linux is written in C, but it just turns out that it's a goddamn mess. Everybody makes mistakes. The code bases are full of bugs basically, and it takes years and years and years to get rid of memory leaks and those kinds of bugs that are related to memory. There's some really cool posts on the Google Android team that are explaining why they're incorporating more and more Rust into their code bases, and they look at the bugs that are uncovered that are related to memory over time. And it's like the first 5 to 8 years that you discover most of the bugs. So after like 8 years, they consider most code bases to be fairly free of those types of bugs if they're well maintained. But it takes a long time to get rid of those memory bugs, basically. And so this is why the whole like virtual machine and garbage collection was invented, right? So you have Java coming in on the other side, and Python and JS, and they're saying you don't have to manage your memory, and that'll save you a bajillion memory bugs, right? So this is super, super powerful, and this is why Java was so popular, because it allowed people to write without caring for memory, and their goal there was to do it to be almost as fast as C and C++. And indeed, the JVM has pretty much succeeded at that, right? Like it's not just as fast, but of all things, it's eons faster than Python, for example. So Java did a pretty good job at getting close to native language speed without having to manage memory. And so this has been like the two sides of the coin for forever, basically. And in 2010 or 2011, when Rust arrived, Rust came in and sort of said, well, we're not, we're doing neither of those. We're doing sort of a third way where the mental model for managing memory will change it and will create a situation in which, and this is like, you want to take time to research this, like don't just take my 30-second pitch for it, but Rust, the idea there is that memory is basically owned by these, any object and piece of data sort of owns their part of memory, and when they're done with it, they need to release it, and that memory gets like automatically just like thrown. And that allows you for not having to manage memory manually. You don't go back and say, free this piece of memory, it's freed automatically. The problem there is that you really need to understand who owns the memory, how does it work, and that is quite a journey. And indeed, it's such a popular and such a common journey, this idea of like learning the Rust memory management model, that it's called fighting the memory, the borrow checker. I think that's what it is. So when you try to compile your Rust code, it just throws a bunch of errors because you didn't manage memory properly, and you didn't like deallocate things, or like there's like ownership problems that you didn't code properly. But once you do it right, it takes a few weeks to a few months to get through that phase. Once you do it right, then you acquire the power of native code, just like the speed of C, C++, but without any of the memory leaks and any of the memory issues. So that's why Rust has been such a paradigm change and why it's so popular these days. So this is your 2-minute pitch on why Rust is popular and important. And now we're going to do a bit more plug and play and have fun. So if you go on the BDK CLI repository, you'll find that one of the ways to install it is from crates.io. And it's using this particular line here: cargo install BDK CLI with the features REPL, Electrum, and Explorer. That's what we're going to use. So pull up a command line, if you don't mind. Let's put up one of those. And if you're familiar with any other language, right, the languages usually will have package managers. So if you've worked with JavaScript, right, it's npm, or Yarn. If you've worked with Python, it's pip. And Rust has a package manager, the same thing. It's called cargo. That's all it is. So if you put in cargo install and then whatever you want to install it, you're going to go on crates.io. It will go on crates.io. I'm going to show you what it looks like. And crates.io is the equivalent of like pip.com or whatever it is for Python, or npm, these kinds of things. And there are two types of crates in Rust. Those packages, they call them crates. There's two types of crates in Rust. The first one is a library, so the kind of code that you pull in and then you can leverage, or binary crates. So these are like just binary applications. And the BDK is a library crate, and the BDK CLI is a binary crate. So that's it. It's fun. And then here they tell you how to install it. So this is what we're going to do. Install it directly from crates.io. I had it installed from yesterday. So for you, it'll be like a long like compilation just because it downloads other crates that it depends on it. So I'd like you all to get on your machines or your second screen and pull this up. We're gonna do this. We're gonna do this for maybe 20 minutes, 30 minutes. I want to show you guys a little bit how it works.
Hey, thunderbiscuit. This is Steve. Just wanted to mention that Harsh had a question about default options for Rust up. So yes, I just told him default options are fine. Yep. Anybody else who's got that command there?
Steve is got at least like 80% of the commits on the CLI. So like it's his baby there.
It's a great way to get into the whole BDK stuff, because it's basically a test tool that anybody can use to just play around with all the options of the library without having to write a whole app. So it's a nice thing there.
I recommend everybody spends a few hours on this, and this is not related to BDK per se or Android, right? So just you're on your Bitcoin journey, whoever's watching this, check it out. It's just a really cool way to discover descriptors. We're getting a lot of the questions we're getting on the Discord server is people coming in and they're like, I'm trying this descriptor and I don't know how it works, you know? And that's the basic thing, because descriptors are like a newer-ish thing for Bitcoin, and the BDK is just on the edge of things, right? Where like most of the newer stuff is implemented, so it's super cool to play with. But it also makes it so that people come in and we require descriptors to generate wallets, and people don't know how it works. So it sort of forces you to learn a lot of that sort of stuff. So it's fun. Yeah. So the first thing we're going to do here, and I'm just going to do this with you guys. Feel free to ask questions or whatever. But if I do BDK CLI, it should be there. And I use long version command line arguments, but there's always a short one. In this case, I assume it might be V. It's not even V, it might be V. Yeah, there you go. So we're on 0.2.0, so that's what's on crate. If you want an even later version of that, you can build it from source directly from the repository. There's instructions on there as well, but what's on crate should be good for us. So now I see it. I see that the chats are coming in. Okay. So, and the way to start looking at BDK CLI is to say BDK CLI help. And this is printing a list of subcommands at the bottom there. That's one of some of the important stuff. And so there's a help key REPL wallet. And from there, for example, you can do BDK CLI wallet. And then again, it's sort of like recursive. You can ask for help from there, from the wallet. And then it gives you a list of other subcommands from once you're in the wallet section. And then, I could do that wallet and pick another subcommand called broadcast and then do the help again, right? And then it'll give me the options that are available for me. So it goes pretty deep. There's like 3 or 4 levels deep of commands and subcommands of those commands. So that's fun. And I'm gonna I can't share it in the chat because I don't have Discord here. I can share it in the chat with you guys. The first thing I did last night was to create a wallet, and we're going to do this right now using this command here. BDK CLI key generate, and then entropy, sorry, is the number of mnemonic words we want to have with our seed phrase, and I'm giving it 12 as my default here. And when I put this, I'm being returned mostly mnemonic. So those are the words that we're interested in. Have you seen the BIP39 way of backing up wallets and recovering them mnemonics? Is that something you've seen last week, or should I spend just a few minutes discussing on this? Okay, so I'll keep going. So I have my 12 words, so this will allow me to recover, and I have my expriv. So this is really the first node. It's the root key, the BIP32 root key that will allow us to generate wallets. And I've taken this and put it into a descriptor. I hope you see my screen, but do you see that the tpriv here is the whole length, this whole thing? And then I add the chat is blocking me. And then I add a wallet path to that. So this will actually generate a wallet for me. And my first command at the beginning you see is REPL. And REPL is a read eval print loop. That's what it stands for. It's a common sort of thing for CLIs where like you enter this sort of mini loop where you give it a command and you're not sort of exiting the process. You're still in it, and you can give it more commands, and it keeps like feeding you, responding, giving you more stuff. So that's what I want to do here. You don't have to use the CLI this way. You can every time to do BDK CLI wallet and then give it a whole bunch of things, but I like to use the REPL. I think it's a good way to approach it. So that's what we're going to do for now. So what I'm doing here is I'm opening a wallet using this descriptor at this particular path, okay? The REPL. And when I do this, I get these 2 triangles, these open angle brackets, and now I'm in. So I can do help. And now they're not arguments anymore. They're literally just commands. So help is printing this, cool. And I can exit. Boom, I'm back. I'm back in my CLI, right? So I'm going to go back and reopen this CLI. Now I'm in this wallet, right, that has this descriptor, and I'm going to sync this wallet. And I can do, for example, like I'm going to print the commands, but here you might find get balance, get new address. There's a bunch of stuff that we might want to use. And the first thing I'm going to do here is get address. Oh, it's get new address. Sorry. So I'm being given an address here. Great. My first address of my wallet. Are you familiar with wallets that sort of generate many addresses? The sort of like the BIP32 type wallet, multi hierarchical deterministic wallets. I'm not too sure of where Callie is it Callie, the way to pronounce his name, from last week or the week before, left off. So I hope I'm not like jumping too far ahead for you folks. Let me know if there's anything else. Maybe one thing I want to take the time to explain. When we're looking at a descriptor here, we have this sort of like root, the BIP32 root key, and then we're giving it a path, right? So this is like the locations at which we want to derive the addresses. What time is it? 8:47. Okay, so I'm still within my time. I want to take a minute to talk about private keys, right? Bitcoin wallets. What's a Bitcoin wallet, right? You heard about this, and you're like, okay, so this wallet has addresses, and then it controls keys, right? There's these private keys, public keys, and I think that the important part this here is to understand that a key is simply a number, right? There's these things called a private key and a public key, right? And we use this public key to create addresses, and people send to those things, and we can unlock those. We can sort of spend with those using the private version of that key. So, but this pair, this duo, is really just one number. It becomes two because we derive deterministically, we derive a public key from a private key. But the private key is the only part that matters. You have a number, and that's just a number. The private key is just a number. That's mind-blowing at first when I understood that it was just like 27 is a perfectly valid private key, right? 2100 is a perfectly valid key. 2,700,229 is a perfectly valid private key. And from this private key, we derive using fancy math, right? So it's elliptic curve cryptography, but it could be anything else really. It's always just like deterministically we arrive at a mirror, not a mirror, sorry, a sister number. That's the public version of that. So, and what's special about this function that we use to derive it is that once I have the public one, it's easy to verify that the private created the public one. But if I just give you the public one, there's no way for you to know what the private one was, right? So I give you one number and you don't know what the initial number that created it was. But if I tell you what it was, you'll be able to redo that process and arrive at the public one and say, oh yeah, that he's right, 27, right? So I'll give you that as homework. Like if I take 27 as the private key, can you figure out what's the public key of the number 27? I don't even know. There must be tools on there to do it. I've never done that, but like post in the chat if you can figure this one out. The private key is 27. What's the public key? But anyway, so what we need to understand is that a Bitcoin wallet is simply a number, a series of numbers, right? 27, 29, 2,700,000, right? All of that is just big, gigantic numbers. And we need to keep them, and we need to hold them. We need to be able to sort through them. We need to be able to parse them. We need to be able to search through them, and we need to be able to back it up to recover them later on. And one way we could do this is having just a big dump on a USB key and say, all these numbers, they're important for me, and I'm going to keep all of them. And I could just write them down on a piece of paper if I wanted to, right? And this is one way to do it. And actually, this particular way to do it is called the bag of key model. It's not really exactly like that, but Bitcoin Core used that for a long time. That it was the primary way to create wallets, where it would just like create a new number, and you had to remember it. You had to save it. You had to back up your wallet file. And but this is sort of like prone for errors, and if you forget one, or your key gets corrupted, it tends to not go very well for you. And so instead, what we do is we have this deterministic way of saying, we're starting with this one number, this one important number, and from there we deterministically decide all the other keys we're going to derive from this. And when we say deterministic, is just we use a specific pattern that is recognizable and that everybody can use. It's the same. So it could be, for example, +5. So I could say my wallet is going to start from this number, and say 27 would be my first address, my first private key, and then I would add 5 to each one. So if I had that as a structure, I could just give you my first one, say, hey, my first this wallet, the first private key is number 27, and you'll be able to derive an infinite number of addresses from this. You'll be able to say, oh, so all of his private keys are 27, 32, 37, 42, 47, right, until infinity. So this idea of like having some sort of rule set that allows you to derive other keys, other numbers. Again, I'm just talking about numbers. The question is, when you have a number, where's the next one, right? And this rule set, there can be an infinite number of rule sets. So nothing says that you have to pick a specific one, right? So where do we go from there? And this is what these Bitcoin improvement proposals are sort of like addressing, this idea that you could go in an infinite number of places, and we need to decide, and we need to help each other. We need to know what other people are using. So this is kind of like what we're doing with these wallet descriptors. We are giving the wallet a way to unequivocally know what the process was and what the rule set was used. And when you look at this descriptor here, it's what's in the string on my line 13. I'm using a particular process called witness public key hash. So that's telling the wallet, okay, it's this one, and then I'm starting from this particular point, which is the tpriv number there, and then I'm giving it a path. So that's another piece of that puzzle of like saying, well, I'm going to derive addresses at these places. And so it's letting the wallet know how to find all the addresses, because there's an infinite number of places you could go. And by providing this descriptor, we're saying, this is where I'll be generating addresses at this particular, using this particular rule set. So I was saying you could use +5 on every number. In this case, it's a whole different other rule set, but that rule set is defined. And when a wallet sees the descriptor, right, the description for that rule set, it becomes very, very clear what it needs to do. So the wallet is like, oh, sure, I know what to do. Right, this is a BIP84. I know it immediately. Even me, I look at this, I know it's a BIP84 because of the 84 here. And so those are defined in a whole set of Bitcoin improvement proposals, which you might have talked last week or 2 weeks ago. And this is sort of like beyond the scope of this this workshop. But these wallet descriptors, that's how they work. We're providing the wallet with a very unequivocal, simple, and very definite way of deriving a set of addresses. So if I give the wallet this particular descriptor, it will derive an infinite number of addresses, but it will always derive the same one. So I can like send you this string in a text. Don't send your descriptors in text, but I could send you this, right? And I will indeed do it. I'll do it in the chat because this is a testnet wallet. I'm going to send you this string, and you can post this in your command line. And if you put this in your command line, you'll generate the exact same wallet as I am all the way, in India, because it's simply deterministic. You could cut off your internet. This has got nothing to do with the network. You're not touching the network at any point in this particular one. Once you have Rust installed in BDK CLI, you don't need the internet at that point to generate the wallet. So it knows what to do, and it's just mathematics. So it'll figure out millions of addresses for you. You can press that. You can ask, get new address. You can ask it like 1,000 times. It'll generate a new address, and it'll be the same addresses for me and for you. Okay. Any questions on this? This was a big rant. I went like deep there, but I wanted to give you a bit of background there for wallet descriptors.
I think somebody asked what this particular descriptor is doing. Maybe it's just worth mentioning that it's for a single key, or it's for a single, like a single key basically. So it's a single user basically that would control this with a single. It's not a multi-sig sort of thing. It's a single public key. It's a pay to public key hash, which you can sort of see in the beginning of the descriptor WPKH. That actually means a witness public key hash. So that means SegWit for anybody who's familiar with the difference between a SegWit and a non-SegWit Bitcoin address. That can be read from this descriptor that thunderbiscuit's using. And then the rest of this path, as he was explaining, just points you to which part of this deterministic tree of addresses you're actually going to be pulling from in simplistic terms.
Very well said. Okay, so I see that Sandipan, is that how you pronounce it? You've got an error that you'll have this, everybody will have this all the time. And I had this in my note. I want to talk about this. So BDK CLI does a bit of like help for you. It creates this little cache of addresses and transactions that it puts aside for you. And it has a checksum on that cache. And if you create a new wallet without giving it a specific name, so it goes into that default wallet cache, it'll find that the wallets are different if you've created another wallet before. And Sandeepan, I know that you're one of the contributors to the BDK CLI. You had a PR that was merged yesterday. Very congratulations, by the way. And that's why it's happening to you. And that's why it's happening to me as well. Because if I create a new wallet for this, like this always happens. So I'm going to put this line here in the chat as well. What you need to do in this case is just to delete that cache. So whenever that happens to you, if you've been playing with the CLI, you've created probably a lot of wallets. One way you can deal with this is by giving your wallets names. So I think it's the subcommand is name or something like that. And then each wallet could have a name if you want, but you need to use that name every time you call the wallet. The other way to do it, if you're just sort of testing around, is just to remove that cache every time like you create a new wallet. So you remove, and then the RF flags are recursive and force, so like you just remove this whole cache, and that'll
yeah, the flag is -w, so it's BDK CLI wallet -w if you want to give the wallet a name. That'll separate your, but it is, as thunderbiscuit mentioned, it's just purely cached data, so it's okay to delete it. You're not storing any private keys or anything in the file system here, so it's fine to delete. It'll just, when you hit the sync command, it'll repopulate that for whatever new descriptor you've specified. But for testing, as thunderbiscuit said, it's convenient to just give the -w option. If you're playing with multiple wallets, that separates them into separate database files.
This is a really important point that Steve is mentioning there, and I want you to really understand this. The descriptors allow you to reconstruct a wallet from scratch, right? And you can, and this is deterministic. Again, you will always end up with the same addresses. And if funds have been sent to these addresses, the wallet will find those funds. So you could delete the wallet. It doesn't matter at all. If you have a descriptor, you're fully able to recover anything. So it's like having the 12 words basically, right? So really important there. So the idea, because a lot of, I think when we start with Bitcoin, the idea that the funds are on your wallet per se is very pervasive. Like we think like if I delete this wallet, but the truth is you're able to recreate these wallets if you have the right backup information. And so that's what's happening here with the descriptors. Descriptors are fully, you can start from scratch. So you delete this cache, it doesn't matter. You can use the descriptor to reload the wallet. And then the thing is, it'll have nothing in the cache. So it won't know about the transactions you've made. And you can just sync, boom, good to go. It'll pick up on all the transactions you've made. And this leads me to the next part of what I want to talk about here, which is Electrum servers. The CLI uses Electrum servers, and the BDK JNI uses Electrum servers as well. Actually, no, I'll keep this Electrum server for maybe a bit later, but right now, let's just assume that when we say sync, it's able to find the blocks with the transactions that we have, and it gets the information it needs to create transactions. So I have this. I'm going to re-enter my wallet again, and I'm going to sync it, and then get new address. And I'm getting this address. That's good. I wonder if I do get balance. Okay, so we have 0 Satoshis in this wallet. And this is the part that feel free to start playing with it as well. If you do a get balance, you should get the same answer as me. So you have 0. And what we're going to do is we're going to grab this address and we're going to send Satoshis to it. So on the PDF document that I sent you, you'll find a section called Tools. And on there, there's the Bitcoin testnet faucet. Is everyone seeing this? This is one of the faucets that I like using. Works super well. And what we do is there's this little CAPTCHA, and then you give it an address, and then you give it an amount of Satoshis you want to send. This is denominated in Bitcoin, and I'm just going to send it. Simple.
I don't know if you already mentioned it, but it might be worth mentioning at this point too that testnet, I'm sure they already learned, is, you know, these aren't real Bitcoins and all that, but the reason we need these faucets is just because they still need, at least for testnet, they still need to have people mining them. So you still need some way to get the coins, and these people that run these faucets, either they're miners or they're talking to people that are mining this test Bitcoin. Yeah, they just pass it out for free for people like you guys who want to test with it.
Yes, very good point. Testnet coins are not worth anything, but they're very important. Software developers use them all over the world. We don't want to just like destroy those. We don't want to waste them in general. It's important not to, don't waste your testnet coins. So, and you'll find that every faucet will have donate back to the faucet address. So this is what's here at the bottom of my screen there.
Yeah, send your testnet coin back there. Don't send any real Bitcoin there.
Yep. A lot of testnet faucets will also offer to addresses to donate if you want to donate to the project. So if you've been using this testnet faucet for a while, I obviously suggest sending a few Satoshis to them. They have a donation address. But those are very different, right? This is like real Bitcoin you want to send to this address that starts with a 3. But at the bottom, I have an actual like testnet address that starts with an M. This is where we'll send our testnet coins back by the end of this. So I've sent this. It's telling me that the transaction went through. And if you look into my tools, I've added another link called mempool.space. Mempool.space is a super cool project. It's a block explorer. So I don't know if you've seen this before. If you have not, you should check it out. There's a bit of like data visualization in there. It's worth exploring. It's a very nice website. And I think there's 2 main maintainers of the project, and one of them is called Wiz, and he's one of the mentors for the Summer of Bitcoin project. So I'm sure 1 or 2 of you guys is working on this. If I'm not mistaken, I bet one of you guys is working on this website right now. Yeah, Wiz and Soft Simon, that's right. Raise your hand if you're working on mempool.space. Good for you folks. This is like, everybody uses this. This is a really, really, really cool project. So, so here we are. I need to choose testnet, and testnet, one of the logos is like this sort of like greenish Bitcoin sign. So the orange is mainnet, and testnet is this green thing. It's also what I used for the app. And if I put in the hash for that transaction, I'm going to find this transaction, and it has 0 confirmation. So it's still in the mempool. It hasn't been mined yet. I'm seeing it here at 0 confirmation, but it is there. And you can see it here, the output, it was sent 0. Blah, blah, blah. So what I'm going to do is go to my CLI, and I'm going to say sync. And from the sync, now if I do get balance, 210,000 Satoshi. So that's good. Other people have been sending Satoshis to the address probably. So if I do list That's another one we could do. List transactions. There you go. 3 of you guys have been sending testnet coins to this address, so that's great. Keep sending it. We'll send it all back by the end of it. So if you have another wallet, this is you can send satoshis to this address, to these addresses, right? Any of those. So now if I do get new address, notice that it always produces a new one. So and there might be a way to print the index there, like we talked about how it's deterministically printing addresses for you. So there's the first address, second, third one, right? And the wallet's just going one by one, very, very cleanly. It's just giving you the next one in the pile. And Steve might be able to tell us if it's an argument I can provide right now, or if it's not in the 0.2.
Yeah, that hasn't been put in yet to show the index, but it'll hopefully be in soon.
Okay. So I don't have a way to see the index of the address, but it's coming, folks. So that's cool. Now I have this address. Now we have transactions. We have funds, right? So get balance provides me with some funds. 210,000 satoshis, which is great. And I'm going to try to build a transaction and send it back to the wallet. Okay. So what we're going to do, and we can do this together if you wait till I do it, and then afterwards you folks can all do it. I just, because of the syncing things, I don't want things to get messed up too much, but what I'm going to do here is to say, and I'm going to check my notes. Oh, okay. Before we do this, I want to show you a website called the Bitcoin Dev Kit by example.com. And this is sort of going through a lot of the Bitcoin Dev Kit, but there's a lot more. So, and the only 2 sections that are really developed right now is the Rust part, which is not even that up to date, and the command line part. And this is what we're using today. And as you discover more of the Bitcoin Dev Kit and the CLI, I recommend you actually go through all of these. This is super easy. It'll take you like an hour or 2. But after that, you'll have like done a lot of like the basics. And if anybody's interested in contributing, I'm the maintainer of this website. You can open a PR to this. If you want to update some of the code, there's some new command line arguments that have come in. Maybe you want to, add a few things, correct a typo here and there. Please feel free to open a PR. And this will give you like the gist of what we're doing today. And I'm going to go into the sending coins section. And in this section, you'll see that the basic workflow to send a transaction using the Bitcoin Dev Kit is a 3-parter. First, we create a transaction, right? Which will output a PSBT. I don't know if you're familiar with PSBTs. Can anybody in the chat tell me if PSBTs were explained in the I don't want to spend time on PSBTs too much, but the idea is that Bitcoin transactions are a list of are basically, right, these encoded pieces of data that we submit to the network. So a Bitcoin transaction is a list of things that are like, they tell you about what the previous outputs that you're using that you want to spend on, and like where you want to send them to, whatever. I'll give you just a quick, this is a blog post I wrote a little while ago. This is an example of hex encoded Bitcoin transaction. So this is the kind of thing you send up to the network, and then the network decides if it's valid or not. And these are easily breakable, right? We can break them into little parts, what's in it, and then they each, if you look at this, like all the colors, I've colored them so it's easy to see what's what. And you'll find that there's a ton of these parts. And what I'm trying to get at here is that these Bitcoin transactions, a lot of the parts can be pre-built by software that does not possess the ability to sign a transaction, right? You might know the public key. We talked about this number that you might know of, And to sign a transaction, to show legitimacy of ownership of these coins, you need to show the private key that's associated with that, right? And everybody can just like verify that it's indeed the right private key. But you don't need the private key to build a lot of the metadata for the transaction. Somebody could say, can you build this transaction for me and I'll sign it later on? And this is what you're going to need. These public keys, I want to send to this address, this multi-sig thing. I want it to be, you know, these lock times, these whatever, can be very, very complex, but they don't necessarily have to be signed by me. So that's step number one. The part number one, I want you to understand, those are completely separated ideas. The idea of like building what the skeleton, right? What needs to be signed is separate from the idea of signing it. So that's number one. And then once I've built it, right, it can be sort of an empty skeleton where like I have all the pieces, but it's not signed yet. So if you send it up to you can send it to the network, right? There's nothing but preventing you to, but if you send that, all the nodes are going to reject it. They're going to say this transaction is not valid. You haven't signed it. And so you're going to need to sign some of the inputs that you want to use some of the inputs to send them, right? But they need to be signed. And if you want to sign those inputs, you're going to need to know the private keys. And that will require a wallet that's in possession of these keys to be able to sign them. And a typical, like the wallets, like for example, a BDK CLI wallet or a Bitcoin DevKit wallet will recognize the addresses that that are in control of basically, that it's in control of, rather, sorry. And so the Bitcoin DevKit can say, oh, say I have a huge setup, right? This transaction sends to like 8 different people and I'm using like 100 UTXOs for it. And me as the Bitcoin DevKit, I might have like 20 of these UTXOs that are mine that I can sign for, but another 80 that are not mine. I can't sign for those. So that's the other part of this is that I want you to think of Bitcoin transactions as being these things that we can build iteratively. I don't need to build it all in one go. I can sign part of it. I can sign part of it today and sign the other part tomorrow, right? And so as long as I get that sort of like block of data, that's the skeleton that's empty, then I can start filling in the pieces that are required. And it's even possible that I don't have all the pieces required to sign it. It's possible that I can only sign one of the 5 things. I can only provide one of the 5 signatures. And now we're getting into multi-signature schemes and things like that, which you've heard about. But this is how I want you to think of Bitcoin transactions. There's these big blocks of data, and they're not, you don't have to, you can just transmit them half done if you want to, right? Except that if they're half done, the network will never accept them. But you can also pre-sign them without broadcasting them to the network. Whoa, hopefully, like, I'm not blowing your mind yet, but now you got to start thinking, wait, what? So I can like sign all of this, but not broadcast. What would I do with it? Now we're getting into Lightning Network, and I don't know how far you've gone into Lightning Network, but that's basically the idea of the Lightning Network. We're building these transactions, and they're signed, they're ready to go, but we're not actually broadcasting them to the network, which is hilarious. Like, what are you doing with it? Well, you're trading them around, and they're ready to be broadcasted. So if ever there's any problem, you just broadcast, boom, gone. But if there's no problem, we can just keep trading them. Oh, I'll give you this one, I'll give you and then back and forth, and then if they get exchanged and chains, and I don't think we want to get into that, but that's the idea. And those blocks of data, like I have here, the colors and all that stuff. What else do I have in this? I don't think I have any other visuals, but yeah, this piece up here. It's not exactly like this, but we have this idea, and it's called a PSBT, a partially signed Bitcoin transaction. This idea was introduced a few years back by Andrew Chow. I think him and Peter Woolley at Blockstream, and I think there was a third person, but they made the initial BIP for this idea of having these partially signed Bitcoin transactions. I shouldn't talk about Bitcoin history on a recorded call here. I don't know. I might have messed up their names or the exact people that are. I want to give credit, like these folks have built, but I think Andrew is the main guy behind the PSBT at Blockstream, the PSBT idea, and this is what happens with these PSBTs. We create them. We can create them completely empty, like no signatures are in there, but the metadata is all in there. And then we pass them around to the right people who need to build them, who need to sign them. And this idea is very powerful because you can imagine that even me as a user, I could have two sort of like parts of me, two pieces of software that do completely different features, completely different, have different purposes. One might be to build those transactions, but not sign anything because it's a hot wallet, it's connected to the internet. I might be worried about, hacking or any other thing that I'm worried about. Or I use software that I'm not as certain with, but maybe I can just build this sort of like skeleton that's empty. And then I can pass this data, this PSBT, to a device or a piece of software that I really trust. But maybe this other device, and this is what where I'm going with is hardware devices, for example, are a great example of that, where like you could give a hardware device a PSBT and it would recognize some of the parts in there as signatures that are required by the hardware to be signed. And so it would just like sign the pieces that it can sign and then return it to you. Say, here it is. These are the pieces that I could sign, and then do whatever you want with it. You don't have to broadcast it, and maybe you're missing more signatures, so you need to pass it to another hardware device, right? But this idea of like having this PSBT is important, and that's how we do it. So PSBTs are a bit newer and very powerful, and that's what the Bitcoin Dev Kit is using. We're doing a lot of stuff. I hope I'm not overwhelming anyone. And I know you came for an Android workshop, but there's just the Bitcoin Dev Kit is so much more than that. And I want to make sure that we go over some of these important parts. So the next part here is to look at this thing where we want to create a transaction, sign the PSBT. So we can all do it ourselves in this particular case, right? I can create the transaction. So that's empty of signatures. It's a PSBT that the skeleton is there, but it's not signed. Then step number 2 will be to sign that PSBT, all the UTXOs that I want to sign. And then the third one will be to broadcast it. So those are the 3 steps we're going to do, and we're going to do them right here. And the first thing I want to see is sync get balance. Okay. This is still our balance. Nobody's spent from it. Nobody else sent to it. So that's good. And create TX 2. And then I give it an address. I think actually those need to be in quotation marks. And we're going to send 5,000 Satoshis to it. So this JSON object is what's returned, and there's a TX ID. I mean, there's all sorts of stuff here, and the
actually I can mention real quick here too that the change that Sendipan made was so that this PSBT would also be displayed as a JSON structure in addition to the serialized format that you see here. That's not in this current version, but that's the PR that he worked on. So
nice.
This is how it shows up.
Yes, because you'll find the PSBTs are encoded, and this is base 64 encoded. Am I right?
I think so. I'm not 100% sure, but I believe so.
We'll say it's base 64. If you know for sure, let us know. But it's actually data, right? There's like pieces of data that it's fun to sort of see through it, to see it. So being able to parse that PSBT in JSON format and see what are the pieces that are missing, what's the metadata that's included in a PSBT is super interesting. So again, another example, like the CLI, go through the CLI. It's really worth it. But for us right now, I have a PSBT. It doesn't matter that I don't really know what's in it. And what I'm going to do is to sign it. So my step number 2 is to sign the PSBT. So I'm going to do sign PSBT. And then in quotation mark, I'm going to put that PSBT. And what's returned here, this is what came back, just so we're clear, is a JSON object, and you see that it says is finalized true. So we're seeing that it's ready to go. So this PSBT is finalized. It has all the pieces that it requires to be broadcasted. So the CLI lets us know, hey, this is ready for broadcast. Because in a lot of cases, if you go through the Bitcoin Dev Kit has a blog, we have an official website. It's in the link for the PDF document, and you'll find that there's a lot more you can do with it. And obviously, you can do multi-sig systems in which like each person would sign iteratively, right, one more part of the PSBT, and at each step there, the PSBT is signed by one more person, but it's not finalized. You could broadcast it, and it would be rejected immediately. So this is what this argument is saying there. In this case, we're ready to go. So I've copied that string, and step number 3 is to broadcast PSBT, quotation marks. I got my PSBT. It's ready to go. Let's fire it up. And I got a TXID. Sick. And now if I do sync, now notice that if I do get balance here at this point, I still have the same amount because I haven't like synced back to the network and say, did this transaction really go through or whatnot, right? So we want to do another sync, and now I get balance. And notice that now we have the balance is down by the 5,000 plus the fees. And what I'm going to do is go into this mempool.space, and we find our transaction. Check this out. Neat. So, and this was our address, the MKHS9, NE1, whatever. This is the testnet faucet, right? We're sending back to the faucet. So we'll make sure that we send all of our funds back to the faucet by the end of the day. But I want to keep some funds in this wallet. Feel free to use it. The only thing is like we're a lot of people, so it might be easier if you want to build your own. It might be easier, and you can go through the tutorials here, and they'll show you how to create your own wallets and use the help a lot. And the help will basically show you how to build everything, so it's super fun. But you can also try spending and sending to this particular wallet. You have the descriptor now. If you save it in a file, like you can use it anytime. The only thing is make sure you sync all the time, because if a lot of people are using it, then you'll have like cross fire there. Some people will sign certain UTXOs, and then they'll have it broadcast it, and then you try to broadcast yours, and it'll say that it's invalid because those UTXOs have already been spent by somebody else. So because we're a lot of people, I suggest you create one from brand new. But if you're not sure how to do it, this is a perfectly valid wallet. Maybe by the end of the workshop tomorrow, I'll clean it up and we'll send the funds back. That's what I wanted to go over for the CLI. Now we've talked about PSBTs, output descriptors, lots of stuff. It's 9:25. We'll take a break at 10, I was thinking. So, I mean, yeah, I'm on a different time than you guys, but we'll take a break in half an hour, basically, for like maybe 5-10 minutes. Does that, how is that for everyone? Am I going somewhere? Did you learn something?
So are you saying we take a break in half an hour from now, which is 7:30 p.m.?
Yeah, something like that, or 7:30 p.m. for you folks. Or 25, and then we take 10 minutes. I mean, I say break, but I'll stay on, and you can just ask me questions in the chat, or we can like talk about different stuff, but just sort of to give everybody a chance to fill up on coffee or whatever.
Sounds good. So a 10-minute break, are you saying?
Yeah, maybe in half an hour, if that's good with everyone. I'll take the next little while to talk about BDK JNI and Android, and then we'll get going on the actual Android app. after the break, maybe. Again, I'm monitoring the Discord server chat, so feel free to ask questions there. Anything else on this you want to talk about, the CLI? Good. So BDK JNI. We've talked about language bindings, why they're complicated, but why they're worth it in our case. So that's good. I want to talk about Electrum servers because they're an important part of the BDK CLI and the BDK JNI right now for mobile devices. And after speaking with my mentees, I know that they weren't familiar with Electrum servers. So if everybody is, let me know. But they told me they sent me the best mentees of all the group. No offense. And because they didn't know about Electrum servers, I'm figuring that most of you haven't heard about Electrum servers. Electrum servers are really cool, really powerful, and very popular in the Bitcoin world. Oh, sorry, I'm getting a cool notification, but I don't know what they mean. Okay, so you've heard last week the idea of a node, right? So you're familiar probably with the idea of a node, and a full node is a node that will go through every transaction that's ever happened on the Bitcoin network, and it keeps track. And by going through those, right, if you go through all the transactions, you'll be able to tell all the UTXOs. And I'm using UTXOs here, just assuming you know what a UTXO is. Let me know if not. But assuming that it knows, eventually it'll go through every UTXO and it'll know all the UTXOs that have been spent and all the UTXOs that are still outstanding, that are like ready to be used by other Bitcoin transactions. And yeah, the ones that have been spent cannot be called UTXOs because they're unspent, but I should say the outputs that have been spent. And so, but the trade-off there is that a full node requires one to go through all this transaction history, right? You need to sync up to the chain. And right now you're looking at like a node is like 350 or 400 gigabytes. So it's like gigantic. It takes a long time to do, but it's the utmost in security. So you're not relying on anybody else. This is it. You're doing everything yourself. Just going to check some of the notes that I had for this. Yep. But in our case, in a lot of mobile development and a lot of like mobile devices, you're not going to want to run a full node, right? For one, you're not always connected to the network. Your phone runs out of batteries, all sorts of stuff happens. You're not always connected to the network. It's kind of like annoying to always sync up and try to stay up to date, but also it's a lot of like download and upload. So usually a node will be communicating and giving blocks to other nodes that are requesting the blocks, and it needs to download its own 400 gigabytes worth of blocks, even though you can prune some of those. A prune node, I'm not sure how big a prune node is something like I don't want to say, but it's considerably lower, because you can discard the transactions that have been spent and that you're not going to need to go back to. But it's still a lot of work, and for most mobile devices, it's not a requirement that ever makes sense. So Electrum servers are this idea that you could take all of the UTXOs that are currently valid, that are ready to be spent, right, and index them all and have them in a database that's easy to query, right? And that you can basically just ping this database and say, hey, what are the transactions here for this particular address? Do you have any transactions for this particular address? And the database is a really, really quick lookup, and would be able to return to you the transactions that are associated with that address, right? And what, you know, if they're spendable and that kind of stuff, all the outputs that are usable for you. And this was initially implemented in Python. So the first, because the Electrum project is a full desktop wallet, and it's written in Python. And so the Electrum server was initially written in Python. It still is. And it became such a useful tool that more and more people were using it. And eventually, this guy Romans, I think he's the initiator of the Rust version, decided to actually build an Electrum server from scratch in Rust. So he re-implemented the Python version, but in Rust. And I'm just mentioning this because nowadays, most people, when you say like, oh, it's an Electrum server, what they mean is the Rust version. So that's the standard. It's called ElectRS. And this type of Electrum server is super popular. So it's very, very used. And what it allows you to is to ping that server and say, hey, I have these addresses. Can you send me back like whatever you got on those, right? And it can do it really quickly. And the beauty of this is twofold. One, it allows you to have this server somewhere else, right? So you don't have it on your phone. My phone doesn't have a full node on it. It speaks to an Electrum server. That's one thing. And two, it allows for very, very quick retrieval of information. So you have not downloaded the full blockchain. You have not verified all transactions. And yet you can sync up a wallet in like 2 to 8 seconds, right? A gigantic wallet will sync up in like 10 seconds max. So it's a really cool idea on its face. So that's the first thing I wanted to say about it. They're very useful, and that's what most mobile devices use, Electrum servers. And now I also want to talk about the trade-offs, because these Electrum servers are not without trade-offs, right? One of the things that they come with is the requirement to first trust this other server. So a lot of Electrum servers are publicly available. So they have URLs that you can ping, and you can just give an address and it'll respond to you with a bunch of transactions that are associated with that address, for example. Super useful, but also you have to trust that this Electrum server is responding to you using correct information, right? That's a big problem in Bitcoin. Like, you don't actually know this because you haven't verified all transactions. So that would be your first big problem with Electrum servers. One type of attack from the point of view of like a mobile wallet, for example, if you're speaking with an Electrum server, the first thing that the Electrum server could do to you is provide you wrong information. So it could say, oh, you have this amount of money and this amount of money, and you have received these funds, right? So if you're paying for a service, or you're being paid for a service, you're sending away something in the mail, for example, and somebody pays you on, using Bitcoin, the Electrum server could say, oh yeah, you've been paid, right? But you haven't. It's just totally lying to you, and you have no way of knowing if the Electrum server is lying to you. So that's type 1 attack there that the Electrum server could do against you. And one way you can mitigate against that type of attack, obviously, would be to connect to maybe multiple Electrum servers. So anytime you ask about a particular address, you could, it's not very common, but you could, if you wanted to, connect to 10 different publicly available Electrum servers. And then if they all give you the same amount of information, then you would say, okay, this is valid. But if there's only one, if you're connected to only one Electrum server, you could be potentially attacked in that sense. So they can't steal funds, obviously, but they could feed you wrong information. So that could be one thing. The other thing they could do against you is withhold information. So it's a type 1, right? So an Electrum server could just decide not to give you information about things, to not tell you that you've received payment on something, and it'd be like waiting for payment, and payment is not arriving from your perspective because you don't have access to the full chain, and the Electrum server is attacking you by withholding that information from you. That's another way Electrum servers could attack you in theory. So those are, I want you to understand some of the trade-offs there with Electrum servers. And we mitigate these attack vectors in different ways. One of the ways, obviously, is you could connect to multiple Electrum servers. So that's one way. another way we mitigate against that is we have our own Electrum servers. And that's becoming certainly more and more popular, is the idea that you might have a full node at home or in the cloud or something, and that full node has an Electrum server connected to it, right? So an Electrum server always needs a full node because it's a database of all the UTXOs basically, right? And it responds to you, whatever. And so you can have, for example, people who have full nodes at home. You've heard of projects maybe like Umbrel and MyNode and Raspberry and whatnot. And those will all provide Electrum servers for you. So they come with a full node, and it's an always-on machine. So you don't have to worry about, it going out of business because you close your laptop or whatever, right? It's not on a mobile phone. It has a lot of like hardware capacity. You can buy something that's powerful enough, and it can hold all the 400 gigabytes or whatever that you need for it, and it can have an Electrum server with it. Oh, sorry, something Maya. Speaking about Electrum servers, it just gets me emotional. It's just so beautiful. No, sorry. And so a lot of people will have these nodes and they have Electrum servers with them. And when you have an Electrum server, it's the first name actually was Electrum Personal Server. So the idea was that it would be your personal little server just for yourself. And this is what a lot of people do. So they'll have Electrum servers that are associated with their node, probably, sometimes at home in the cloud. And that Electrum server, you can open the port to that to a Tor address and only share that address with you. And so on your mobile devices or on your CLI, a very common way to sort of like mitigate against the attacks of Electrum servers attacking you would be to connect to your own Electrum server. So in this case, you still need the hardware. You still need to sync up the chain, right? But you can do it. You can sort of like outsource that work to a different machine. So you're not doing it on your mobile phone, but your mobile phone still connects to your Electrum server. Really cool. And that's becoming very common. And once you have one of those nodes and you have an Electrum server, usually with the Tor address, for example, if you have an Umbrel at home or a MyNode, they provide you with the URL, not a URL, sorry, but like a Tor onion address. I'm not sure if that's the right wording for it, and then you can just plug that in your mobile address, your mobile wallet, and the mobile wallet will still use an Electrum server, but it uses yours. And so you're not going to attack yourself, obviously. So that's one way you can, that's one thing. And another thing I want to talk about before I finish on Electrum servers is the third type of attack that Electrum servers can do on you is sort of it's not quite an attack, but it's a loss of privacy. So when you're using a publicly available Electrum server, like the one we're using with the BDK CLI, for example, or we're going to use today with the Summer of Bitcoin wallet, they use a Blockstream Electrum server. So it's a powerful Electrum server. It doesn't go down. It's always up. It responds really quickly. The uptime is really great. But in theory, you never know, right? So like somebody could, and that's been known to happen, like where Electrum servers they could publicize them. So they could say, hey, connect to us. Like we're an Electrum server. We're free. We're powerful, whatever. But they could collect information on all the addresses that you request. So even if they feed you the correct information, you might be tempted to think it's a great Electrum server. But one of the issues with it would be that it could collect all the addresses that you request. So when you make a request to an Electrum server, it knows your IP address, even though you don't create an account or anything. But it could over time, because you're requesting sometimes multiple addresses at once. You might send a batch of 20 addresses. You say, can we get info on all these 20 addresses? It could actually collect all of that information on you. And then after that, it's able to restructure the graph of your transactions, which is the idea of using multiple addresses, is the idea to sort of like diffuse those types of attacks. So you're sort of opening yourself up to privacy issues. And that's also why people use full nodes. I'm just going to read this, Raj, to everyone. Electrum server is something like a full node with additional features. Yes. Yeah. So I hope I sort of answered there. It's not a full node at all. So it doesn't like scan the network. It doesn't do any of that. So it's always a sister software to a full node. So you have a full node and then you start an Electrum server and you say, this is my full node. And it just like speaks to it. And it'll just like figure out and request the UTXOs, it does everything it does. And then it just keeps a database of all the UTXOs and all the things that are spendable and a bunch of important, interesting metadata about those. And when you need information about particular addresses, you just ping the Electrum server rather than the full node. And the Electrum server is just really, really quick. Okay, I'm reading the chat. I'm trying to send testnet back to the testnet faucet, but since the address is MK, it's not starting with TB1. No, it should send to that address actually. So the M addresses are a type of addresses that is sort of like one back in the hierarchy of how we use addresses. Like the newer ones are the TB1. These are called Betch32 addresses. I think you've talked about this last week, but the M addresses are wrapped, SegWit wrapped, if I'm not mistaken. And so those, but you should be able to send. So if it's returning an error, that's on you. You got some either the CLI is throwing some sort of weird error that I'm not sure, or you're not providing the address and the fee correctly. And remember that it's something like create tx 2 flag 2 and then quotation marks and blah 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 blah, and then colon whatever the amount of satoshis, 500 in this case, and then close question. So this is, I had errors for a little bit a while back because I wasn't using quotation marks between the address and the thing. So let me know if that doesn't work. But I just noticed a few minutes ago that that's part of the documentation here. There's a typo there. It's not using the quotation mark. Yeah. See here. It should be using quotation marks. Yeah. Sweet. Yeah, when you speak to the node or the CLI, it mostly just understands strings. So you want to give it strings, and that's yeah. Cheers. Open a PR. That's it exactly. Let's get going on this. Like this website is I'm hoping sort of a community maintained website of a bunch of examples. That's one way I learn a lot, is by just reading example code. And once you have that, you sort of backtrack into like formal docs and that kind of stuff, and you dig into the library. But I find the other way around a bit harder. Like if you want to start from scratch, building the mental model from nothing is a bit harder than like just seeing someone go through and just like firing up a bunch of transactions. And then once you sort of get it, then you start having questions, but you've got a name for those questions, and you can like search the code base and look at the strings. So the idea of like building examples, hey, do this, do that, for me is like really powerful. This website we're hoping to add to the family of Bitcoin Dev Kit websites. You guys are like super lucky, because this is like you're gonna get to see something that the maybe a preview into what the docs are gonna look like. The first thing I want to show you is the current docs. So bitcoindevkit.org, I think. So this is our current website. It has a blog, which is cool, and Steve wrote something. Actually, Steve and me, I guess, on multi-sig. So if you're interested in like getting into multi-sig, understanding it a bit more, that's a really cool article to read. And there's a bunch of articles on tons of stuff. You got a CLI info. Anyway, there's a lot of stuff. But the Lightning Dev Kit has been working on a new version of their documentation, and we were thinking of sort of like jumping on the bandwagon and maybe having like similarly branded websites. And I want to show you guys what it looks like, because this stuff is fire. They got a web developer to do that work, and there's designers in there. Really good work, really good work from the LDK team and the guy who's developing this. And so again, it's sort of like a Lightning Dev Kit, but we're hoping to have a Bitcoin Dev Kit version of this. And you have all their documentation, guides, similar there. There's some parts that are like fully docs and some parts that are more like examples. There's even a blog that they're working on. Oh, actually, these are our blog posts. So I think he's using our blog posts as sort of examples and, you know, dark theme, the whole thing. So I think that's going to be really neat, and check it out. And these are the things that, I mean, I started with the Bitcoin Dev Kit back in June last year. And for 2 months, I worked on docs. Like, you know, I made a bunch of PRs on docs and worked on the websites. And that's how I sort of like got going and eventually moved into more. But it's a really good place to start. Go through the docs, try it yourself, and you'll actually find mistakes. Like, this is genuine, you'll find mistakes. And the other thing you'll find is that the new versions are not necessarily all matching, right? You might have new APIs that are working. And so you might gain from like seeing it and trying it, and then you'll find mistakes or things that can be added. Say, hey, now we have like the index, like Steve was saying, the index of the address is coming in the next release or something. So that's something we want to add to the docs. But the guy who built the docs initially is, you know, doing some other stuff. So yeah, it's a really cool way to contribute, is to open PRs for documentation, these kinds of things. Anything else you want to ask about Electrum servers? Because they're very important, and it's important to understand the trade-offs for us, because we're mobile wallet users, and in our case, we're using Electrum servers, and it's a really cool project and cool system, but you need to know what you're giving for it and what are the options. And the CLI is using that as well. But you'll notice as the CLI, there's other ways also to collect. So this idea of using Electrum is because you're going to need block data, right? You need, without being a full node, you need, because you don't have a full node on your phone, you're going to need to acquire that block data, that information, like what are the UTXOs that I can spend? What are the UTXOs that have been broadcast? Which ones have been mined? How far are they back in the chain? That kind of thing. And so this idea of getting block data, you've seen probably with Kali, block data can come from different places, right? And they all have different trade-offs. And so that's also something that Bitcoin Dev Kit is working on, is the ability for users to choose how you're gonna acquire your block data. So they give you different pros and different cons depending on what you want to use. But for us, it's only Electrum data, but there's other things like the compact block filters, for example, would be a good example for mobile, which I don't know if you've heard about last week, but that's an important part that maybe for the BDK JNI, eventually you'd want to be using that instead of an Electrum server, that kind of thing. So anything else? It's 10 minutes to on my time, so I'll keep working on this I'll keep going for another 10 minutes, and then we'll take a small break. Everybody's good with that? I'm seeing Carolee. Hi. Welcome. I'm trying to figure out what I want to bite into for Android. I think I'll just get started with Android. And the first thing I think you should understand if you're new to Android is that, well, first of all, the workshop, you don't need to be an Android dev to benefit from the workshop. I think a lot of it is got to do with using the Bitcoin Dev Kit. And again, like the past like 2 hours, we're not about Android per se. So, but Android is a framework, and it's not a library. And if you're not familiar with the difference between the two, I think it's important to take a minute to talk about this. When we use libraries are these things that somebody else develops, or maybe we develop, but we pull them into our code and then we use whatever we want out of this. So a library, somebody who maintains a library or creates a library, like the Bitcoin Dev Kit is a good example of a library, might give you an API, right? It comes with 200 functions that you can use. So you pull it as a dependency in your code, and then you use whatever you want out of this. So it's sort of pick and choose. The idea of a framework, and those are not like fully defined. It's not like there's a line in the sand, but in general, when we speak of a framework, we speak of us playing into somebody else's turf. We're playing into somebody else's code. That's what Android is. Android is a framework. You write code that the Android framework will be able to run. So a library is code that I run in my code, but a framework is code that I write so that it can be read by somebody, by some other piece of software called the framework. This is what the Android framework is. And it's usually, you know, probably about frameworks if you come from web development, but like, you know, React, Vue, there's frameworks for all sorts of things, right? JavaFX if you develop desktop applications. And frameworks are very, very powerful because they can allow the encapsulation of a lot of complexity, and they offer you a very clean way, like a few buttons, like the API is simple, not that simple in the case of Android, but and then in the background, they do all of that work for you. They do a lot of work. That's what Android is. It's really a framework. So when you're playing with Android, you're not playing with a library. You're not pulling in a few Android functions. You're writing code that Android will be able to run, basically, that gets compiled into this sort of like Android thing, right? So that then you can give to the Android runtime. It's sort of JVM, and it'll be able to run. And what that gives you is the ability to work on up to, it's something like 6,000 hardware devices that Android can work on, which is unbelievable. If you had to write all that code and the drivers and all that stuff, you'd never, you'd never provide compatibility for that kind of thing. But instead, what you write is like simple Java or Kotlin code, or there's native stuff as well, and you just give it to the Android framework, and it just runs on anything you want. And it will handle in the background, it'll handle things like, connecting to your camera, connecting to the internet, right? We don't do any of that. When you use the Android framework, you just say, hey, I need the internet, and it just gives it to you. It's unbelievable. It's beautiful. The trade-off there is that you need to understand how Android wants its code, right? What it can take and what it cannot take. So it's very different than if you're used to writing your own software that is just your own, and you use like libraries that you pull and then you use them however you see fit. For Android, if you don't write code in a way that works for the framework, it'll just crash your app. The framework will say, I don't know what you're talking about, right? I need to run in these particular mental models. The other thing it does is it creates a common ground for everybody to understand. So we have these mental models, these structures, the way we build libraries, the way we build applications that are very common across Android applications. And these allow code bases to be compatible. When you're looking at an Android code base, if you're an Android developer, you're quickly able to get up to speed to how it works. So that's a really useful tool. And so that's my first part there. I wanted to talk about Android. Let me just. Yeah. So this is what we're going to be doing. We're going to be playing with the Android framework, and the Android framework. The truth is, I think that a 2-day workshop is not going to get you up to speed with Android. Like that's not learning how to work with the Android framework is a journey of anywhere between 2 months to a year easily to really sort of like get up to speed and really understand the power of it and being able to use it. But for this workshop, I'm trying to gloss over a lot of what makes Android work. We're going to discuss some of the basics so you understand what I'm doing, why I'm making certain design decisions, and the classes we're using. But in general, there's a lot of things too that I want to leave aside and not necessarily go into. But know that I'm happy to discuss those. So like fire them up in the chat, or I'll stay. Obviously, once we finish here today, I'll stay afterwards, and you guys can ask me questions if you have specifics of like Android. Because at first, if you're trying to build your own app, there's a lot of things that you need to understand how it works. And so examples are like that are activity life cycles. Android has this idea that a screen often will be is called an activity. And these activities are like your apps, and they go through a life cycle. They're not always like on, right? You might have an app that you press your sort of like app button and you switch between different apps. So then your app is now in sort of like background / sleeping mode, or maybe you just like swipe it away, and then your app is just killed at that point. Or maybe you have too many apps open at the same time, and your hardware doesn't have the memory necessary to run all of these at once. And so your operating system, the Android operating system, will actually kill some of those apps in the background. And so it needs to understand what to do with your app, what to do with your activity when it needs to kill it, because sometimes like you don't call to kill, but Android will actually kill your app. So these ideas like of this life cycle for your activity are important, and that's just one example, but there's like a lot of those little things that are powerful, and they allow us to play the game of Android well and give us like optimizations that are unbelievable, but you need to understand how they work to really take advantage of them. And here I'm trying to stay sort of like not go too deep into this and just say like, well, this is sort of how it works. And if you want to dive into Android, like you're going to have a great summer, because this is like really cool stuff. But for the workshop, we're going to do more like Bitcoin Dev Kit. We're just going to make sure that it works. That's what I had for now. Sorry, I've been sharing my screen the whole time. And I've been speaking like nonstop. So I don't know if you've had a chance to really try the CLI, make some transactions, sign some PSBTs, play with it a little bit, explore the help as well. There's a lot of like cool subcommands that you can like play with and have fun with the CLI. And a lot of those will actually end up using in the wallet as well. So they're very connected.